Hello, this is Miss Wong, and this is your first video lesson. So this lesson just goes over a review of acids and bases after all of your notes. And so just a little bit about bases. Some of the things that I want you to walk away with is the two basic definitions of what an acid is, and there they are. An acid is anything that donates hydrogen ions to bases. That's the Bronsted-Lowry definition. Or an acid is anything that produces a hydrogen ion. That's the Arrhenius definition. So here are a couple of examples of acids. And you can tell that they are acids because you see that they have a hydrogen in the front usually. I know sometimes there's hydrogens in the middle, but if there's a hydrogen written in the front, that usually is a clue that you are looking at an acid. And we say that is ionizable because those hydrogens are supposed to be able to be donated as an H plus ion. So that's why we say that they're ionizable. Here is a sample of a strong acid. Was one of the things from your notes, and what they do is they completely dissociate. So that means you have a bunch of these acid molecules. When you put them in solution, every single acid molecule, the hydrogen ion pops off from the rest of the acid. So you can see all the blue hydrogens have separated from the red parts, which is the rest of the acid. Here's an example of an acid equation, or an acid-base equation. The HNO3 is defined as an acid, so a couple of things to look out for. You'll see that when HNO3 is added to water, it makes this H3O plus ion. Okay. You can also see that the HNO3 starts off as a reactant HNO3, but by the time you get to the product, it's lost that hydrogen. So that hydrogen ended up getting donated to the water. And so that, because the HNO3 is donating a hydrogen ion, it makes it the acid as well. Here's another acid example. One of the other things you looked at were weak acids, and weak acids, those have incomplete dissociation. So what that means is when you toss a bunch of these acid molecules in water, most of them stay together. So most of them is still this molecule that's complete, red and blue stuck together. Some of them break apart or some of them dissociate. So some of these hydrogens have popped off. I think there's two. I see one. And then you see two of these ions. So most of them have not dissolved, only very few of them have. Here's another example of an equation, so a couple of things to look out for. This is citric acid. This is the stuff you find in oranges and lemons that make them sour. So again, you see that H that's written in the front. When we put the acid in water, it makes these H3O plus ions. Also, if you look at the acid, it has that hydrogen in the front, but by the time you get to the product, it's now lost the hydrogen. So that means the acid has donated the hydrogen away. So that makes that the acid. Okay, here are some base examples. A lot of our bases we're going to look at are metal hydroxides, which means it's a metal with a hydroxide ion. So here are all of them. You have lithium hydroxide, sodium hydroxide, potassium hydroxide, rubidium hydroxide, cesium hydroxide. You've got calcium hydroxide, strontium hydroxide, and then barium hydroxide. So if it's not one of these, we're not looking at a strong base. Okay. So here's an example of how a base can behave in solution. It can completely dissociate. So here's calcium hydroxide. It will break apart into one calcium and then two hydroxide ions. Here's another one. Here's sodium hydroxide as a complete molecule, but once it's in water, it breaks apart into the sodium ion, and then it breaks apart into hydroxide ions. Okay, these are the easier bases to tell because you can see the hydroxide and you'll know that they'll pop off or dissociate. The other bases that are a little bit harder are the ones without hydroxides, and the only way you can tell that they're a base is you have to look at how that they're behaving in a reaction. So this PO4 right here, this is a base. Here's a way you can tell. One way you can tell is that PO4 has a 3- charge, doesn't have any hydrogens, but by the time it got to the product side, it picked up an extra hydrogen, which means this PO4 accepted a hydrogen. That makes it a base. Okay, here's another example. Here's NH3. That's also a base. So if you look at it, here's NH3 with 3 hydrogens. By the time you get to the product side, it's NH4, so it picked up an extra hydrogen. So that means this NH3 accepted a hydrogen, which makes it a base. Okay, if you a little bit of background information if you want to know, the reason why things like NH3 can be a base is that it has a lone pair of electrons, and those electrons like to steal hydrogens. SO2 is another base. Again, SO2 has a lone pair of hydrogens right there, and it likes to steal electrons from there. Okay, that's just extra information. All right, so that is just a summary on acids and bases and how to look at equations on how to figure out whether it's an acid or a base. If you have any questions, you can always email. Thanks. Bye-bye.